Welcome to the video lecture. In the last video, I have discussed you with the product of a sum, that is canonical conversion of a Boolean expression into the canonical POS form using the truth table method. In this class, we are going to discuss the algebraic method, how to convert the Boolean expression into the canonical POS expression or else a canonical max term expression using the algebraic method. And before starting to the actual problem, I will use to tell you the one note. When you are going to just solving the canonical expression into the canonical expression, Boolean expression to canonical expression, any of the canonical expression, that may be a POS, that may be a SOP, that may be a using mean terms, that may be using the max terms. You should have to know all the postulates of Boolean postulates. You should know all the Boolean postulates. You should know before going to the solving using the algebraic method. Okay, I hope all of you know that Boolean postulates, aware of Boolean postulates, so that I am going to explain you the algebraic method with the one example. We are going to explain this one example. Third example. This is the third example. I have explained one example with the truth table method, and I have given the second example for homework, two literal variables expression, and this is the third example for you using the algebraic method. X plus y into x plus z complement. Just I have told you, when you are going to convert the Boolean expression into the canonical form, you should have to observe first thing, how many literals are there in the system. Here x is a one, y is the another one, z is the another one. So totally we have the three literals. If in case if it is you are going to solve it by a truth table method, in the sense you are drawing a truth table, but we are going to solve it by a algebraic method, so there is no need of drawing a truth table. Here the steps are there, some of the steps are there. I will tell you the steps, then I will go to the solving this one. First step, you have to observe the number of literals available in the system, and then go for some terms in the sense, if it is a three literal system, x, y and z. Okay, now just observe this one. When you are talking about a sum term, x plus y complement is set as a sum term, and x plus y complement z is called as a max term. Just observe the difference here. When it is said to be sum terms, in the sense at least two of the terms or one or two terms will be involved in the just operation, is said to be sum term. If all the literals in the system available in the expression, in the sense, that is called as a max term. Just observe this one, difference between a sum term and max term. So let us come to the problem. First thing, you have to observe the number of literals available in that system. Then go for sum terms. How many sum terms are there? Here two sum terms are there, and in each sum term, what is the missing literal? You have to find out which is the missing literal in the each term, sum term, which is the missing literal. Then how to go for applying the Boolean postulates. Finally, we will get the canonical expression with may or may not with the redundant max terms. Just avoid that redundant max terms and write the expression, canonical expression, that may be a canonical expression, and convert it to the shortened notation by the conversion of binary to decimal method. Okay, now let us see. Just I will solve this one for you. First one, number of literals in this system is a 3, and number of sum terms is a 1 and 2. Sum terms, x plus y is a one sum term, x plus z complement is another sum term. In these two sum terms, next step is we have to observe the missing literal. X, y, z is missing here. X, z, y is missing here. and just write a next step for missing literals. For each missing literals, if it is a one literal is missing, just add the 0, 1 0. If two literals are missing, add the 2 zeros. Okay na? So I am just adding the 0 for Z here. For missing literals, we have to add the 0. For Y, x plus 0 plus Z complement. This 0 is for Y. And now from the Boolean postulates, we have x into x complement is equal to 0, y into y complement is equal to 0, z into z complement is equal to 0. Just wherever it is required, just substitute in the place of 0, which is just in this term, max term, we need a z. So z term we have to replace here or substitute here with a z, that is x plus y plus z into z complement, and here y is missing, so substitute the y into y complement plus z complement. If you are looking at these two terms, have you remembering the any of the postulate in the Boolean just chart, Boolean postulate chart? Are you remembering the any formulas here? As this is nothing but a distributive law. Distributive law where it is x plus yz is equal to distributive law x plus yz is equal to x plus y into x plus z. This is a distributive law. Are you remembering this one, distributive law? I hope all of you remembering this one. X plus yz is equal to how? So, sir, then you can ask how, sir, how it is in a distributive format. Here you have to consider this x plus y as a x, and you have to consider the z as a y. You have to consider the z complement as a z. In the same way, in this expression, these two x plus x plus z complement is treated as a x, and y is treated as a y complement is treated as a z. Just this is an assumption, so that we can replace this one by distributive law. Easily we can convert it to the max term format. So now x plus yz is that, convert it to the x plus y into x plus z. X plus y into x plus z. Okay na? This is the first term. Next term, go with the next term. X, I am writing the z complement at the last, plus y. Okay na? Into x plus z. This is the conversion of a Boolean expression from the conversion of Boolean expression to canonical max term expression using the algebraic method, where final step, not a final step, this next step is how to identify the redundant terms. If any of the redundant term is there, in the sense you have to avoid that one. Just observe here, is there any redundant term? Yes, this is a redundant term is there. Same term available for more than one times. Just replace it by one times. So we will get a x plus y plus z, x plus y plus z complement. This is redundant term, so leave it, x plus y complement z plus z complement. This is the final answer for you. And if you want to convert it to the shorthand notation, that I have told you that use the symbol pi, that is m. This is the value 1 1 1. Sorry, in the max term it will be 0 0 0 0 0 0. So you will get the final value 0 plus, sorry, into is there, multiplication symbol, don't confuse with the, this is a max term. Here 0 0 and 1, where this is a value 1 m 1 and 0 1 1 1 2 4. So 1 plus 2 3. That is m3. This is the shorthand notation, or else you can also write it as a pi m of 0, 1, 3, like this. This is the conversion of a given Boolean expression into the canonical max term expression using the algebraic method. If you have any doubts about this algebraic method, you can contact to the WhatsApp and ask for doubts and try more examples in the home so that you can get this one. And before going to this video, I will say you be thorough. If you are be thorough with the Boolean postulates, then it is easy to understand. And here we have applying this one Boolean expression, Boolean postulate and distributive law. Only these two is applying in a algebraic method. And I will give you the one example as a homework for two variables. Example 4. Just write it down and try it once in a home and send me to the WhatsApp. X into y complement. X into y complement is the, I have given the Boolean expression, converted to the canonical POS form, converted to the canonical max term expression as a max term expression. Yes, it is a completion of your canonical expressions. Next topic is the sum term versus product term, sum term versus a max term, product term versus a mean term is there. And I have explained through the class only. When I am explaining this POS form and SOP form, I have explained you the sum term, product term, max term, mean term. And still, if you are having the doubts in the sense, I will explain that one. Please comment through the for that sum term and max term and product term and mean term. Comment through the YouTube. If you are any doubts is there in the sense, I will make a class on that one. Apart from that, you have the one more topic in this chapter, that is K-maps, simplification of a Boolean expression. Simplification of a Boolean expression in a two ways. One is algebraic method is there, another one is K-maps is there, and I will continue that in a regular classes. This is if you are having any doubts about sum term, mean term and product term, max term. If in that any doubts in the sense, you can comment through the WhatsApp or YouTube. I will make one video on that one.